The universe is filled with huge planets and extremely large stars. While these beautiful celestial bodies are lovely to look at, there are other objects that can cause existential dread. For example, black holes are objects that cannot be seen using most traditional methods. Instead, we must rely on the effect it has on other celestial bodies, such as tearing a star apart. Some black holes are much larger than we thought. Today, we will discover mysteries of the largest black hole ever discovered in the known universe. So, how big is it, and how close is it to Earth? So stay tuned till the end to find out.
Audio Jungle.
Before we look at the largest black hole ever discovered in the known universe, we must first understand what a black hole is. We're going straight to NASA for the answer, which says that black holes are regions of space with such a strong gravitational field that nothing, not even light, can escape. We can't see them with our current tools for detecting light or radiation. Instead, we can only look for black holes by observing how they affect light and gravity in their vicinity. For example, if a star passes close to a black hole, we can observe the impact that it has on a celestial body. The largest black hole ever found in the known universe is found in TON 618. This is a very bright Lyman alpha blob with a black hole the size of 6.61010 solar masses. It has a mass roughly 66 billion times that of the Sun. This supermassive black hole is 18.2 billion light-years away from us. It is situated between Canes Venatici and Coma Berenices. TON 618 is believed to be the nucleus of a galaxy and is one of the brightest objects in the universe. This celestial body still has a lot to teach us. For the time being, we only know that it is most likely home to the largest black hole ever discovered. Of course, with a renewed emphasis on exploring the universe, we might find larger ones. After all, the universe is huge. TON 618 is thought to be an active galactic nucleus at the center of a galaxy, powered by a supermassive black hole feeding on intensely hot gas and matter in an accretion disk. The light from the quasar is thought to be 10.8 billion years old. The surrounding galaxy is outshone by the central quasar's brilliance and thus is not visible from Earth. It has an absolute magnitude of 30.7 and a luminosity of 41,040 watts, or 140 trillion times the brightness of the Sun, making it one of the brightest objects in the known universe. The emission lines in TON 618 spectrum were found to be unusually wide, indicating that the gas is moving very fast. The full-width half maxima of TON 618 was the largest of the 29 quasars, with hints of 10,500 km per second in falling material speeds by a direct measure of the H-line, indicating a powerful gravitational force. TON 618 may fit into a proposed new category of ultramassive black holes. This is because a black hole of this mass has a Schwarzschild radius of 1300 AU, about 390 billion kilometers in diameter, which is more than 40 times the distance between Neptune and the Sun. The massive Lyman Alpha Nebula surrounding TON 618 has a diameter of at least 100 kiloparsecs, 330,000 light-years, making it twice the size of the Milky Way. The nebula is made up of two parts, an inner molecular outflow and an extensive cold molecular gas in its circumgalactic medium, each with a mass of 50 billion m, and both of them are aligned with the radio jet produced by the central quasar. The intense radiation from TON 618 excites the hydrogen in the nebula to the point where it glows brightly in the Lyman alpha line, which is consistent with observations of other LABs driven by their inner galaxies. Because quasars and LABs are both precursors to modern-day galaxies, the observations on TON 618 and its massive LAB provide insight into the processes that drive the evolution of massive galaxies, specifically probing their ionization and early development. Talking about its discovery, a radio survey in Bologna, Italy in 1970 discovered radio emission from TON 618, indicating that it was a quasar. Marie-Helene Ulrich then obtained optical spectra of TON 618 at the McDonald Observatory, which revealed quasar emission lines. So, how big might black holes get? A group of scientists now believe that black holes could grow to stupendously large sizes, each containing the mass of 100 billion suns or more. When it comes to massive black holes, one of the most important questions is whether they can form in the first place. However, much remains unknown about how even regular supermassive black holes form. The common belief is that supermassive black holes at the centers of galaxies form when smaller black holes merge and gobble up matter around them. However, previous research discovered that this model had difficulties explaining how black holes could have grown to supermassive sizes when the universe was only a few billion years old. Another explanation for how both regular supermassive black holes and possibly stupendously large black holes formed hinges on so-called primordial black holes, according to researchers. Prior research speculated that within a second of the Big Bang, random fluctuations in density in the hot, rapidly expanding newborn universe could have concentrated pockets of matter enough to collapse into black holes. These primordial black holes may have served as seeds for the formation of large black holes later on. While some people imagine that a black hole will swallow the entire galaxy, this is not how they work. As far as we know, black holes are not celestial bodies capable of devouring entire galaxies. For the time being, we believe TON 618 is the largest black hole. However, even larger ones may exist that we have yet to discover. What do you guys think? Don't forget to comment down below, and we will see you in the next video.